everyone. How's it going? It's Liz from the Dfinity Foundation, and welcome to the Community Conversations. It's an opportunity for you, the community, to hear from contributors in the internet computer ecosystem, as well as ask them questions live. So today we have our very own senior researcher, Thomas Locher, discussing the current vote to integrate Bitcoin with the internet computer. So remember, the vote closes tomorrow on Friday, September 17th at 3 p.m. UTC. So that's 8 a.m. Pacific time and 5 p.m. CET. So make sure to get in your votes in at the NNS app at nns.ic0.app. So the integration of the internet computer with the Bitcoin blockchain has the following goals. First, enabling powerful Bitcoin smart contracts running as canisters on the IC. And second, making it possible to transmit Bitcoin transactions from Bitcoin smart canister contracts to the Bitcoin network. So Thomas is going to go over a proposed design for the integration of Bitcoin with the internet computer. I don't want to steal his thunder. So Thomas, feel free to take it away.
All right, thanks, Liz. Let me share my screen. All right, let's get started. So let's start with a short agenda. So I will start with some background information and motivation for this feature that we're proposing. And then in the second part, I will go over the proposal itself and the goals of that proposal. So the first two items are geared more towards a general audience. So I assume some of you may not know what it's about. So this will be more high level. So you get an idea whether you think that makes sense, and then you can cast your vote accordingly. And then the third part will cover more technical details. So for those who really want to know how we're planning to integrate Bitcoin. So definitely, if you want to learn these details, stick around for that part. Otherwise, you can skip it. And then, as Liz said, there should be plenty of time for a Q&A at the very end. And also, if there's some questions that we don't answer, feel free to drop them later in the forum where I can also see them. Okay, so without further ado, let's jump into the first part. Let's start with Bitcoin. So I assume that everybody in the call knows what Bitcoin is, so I will not say much about it. I will only explain kind of the parts that are needed to understand what comes in the later slides, so the necessary terminology. So again, a simple example. So Bitcoin is used to transfer money. So Alice wants to send 400,000 Satoshi, right now about $190 to Bob. And for that, Alice has to consume two unspent transaction outputs, or UTXOs. So that's a term we'll hear plenty of times in this presentation. She has to spend these two, which sum up to 400,000. So that's essentially how Bitcoin works. As you know, there's a transaction being created with these two transaction inputs that are being consumed and a new output that is being produced. And the inputs were outputs from previous transactions. And the transactions are collected, forming a block of transactions. And these blocks are then chained up, forming what is called the blockchain. So this is essentially everything, all the terminology we need for Bitcoin. Moving on to the internet computer. Again, I assume that a lot of people know what the IC is about, so I will be brief here. So it's essentially a big public cyberspace for smart contracts running on top of the ICP protocol, which itself runs on standard IP. And it's a very nice protocol, and a nice stack, because it's fairly easy for developers to get their hands on some cycles which are needed to run your canisters, which encapsulate your state and your smart contract logic. And it's fairly straightforward to deploy. your smart contract and also easy to interact with it using standard browsers. For those in the call who've never tried it, I recommend to try it out because it's actually quite a lot of fun and there's good tooling available to try it out. Okay, so we have these so-called canisters that can run arbitrary smart contract logic. And how do we combine that now with Bitcoin? Well, if we have canisters that can hold Bitcoin, which means that every replica running the canister code together share a Bitcoin address, then as a user, I can send Bitcoin also to a canister, right? And the canister has logic in it. The smart contract logic essentially defines a Bitcoin smart contract. And that logic may say, well, I'm going to, when some conditions are met, I'm going to send Bitcoin to another address, which might belong to another canister. And that logic might say, might pay out Bitcoin to another user. Okay, so that seems, so in summary, if canisters can hold Bitcoin, we can use canisters to implement arbitrary Bitcoin smart contracts. And that is actually quite nice because if you think about it, Ethereum came about because Bitcoin lacks expressive smart contract functionality. It has its very limited scripting language. And with this integration, essentially, we are enabling smart contracts for Bitcoin, which I think is pretty cool. All right, so that was already the first part. Now let's talk about the proposal. So the goal is, well, first of all, as I mentioned before, we have to have canisters that hold Bitcoin addresses, so you can send Bitcoin to these canisters. And that alone, of course, is not sufficient because canisters should also know about their funds. So what do they have available to work with? And for that, we need to integrate with the Bitcoin network that feeds blocks straight into the internet computer and that processes blocks and makes the unspent transaction outputs, the UTXOs, available to the canisters so that the canisters know, first of all, what their current balance is. And also, of course, if they want to spend it, they would need the UTXOs anyway. So that would be the second part then. If I have my UTXOs that I can spend, I can satisfy the scripts and create transactions, which the internet computer would then send out to the Bitcoin peer-to-peer network so that they get put into one of the next blocks. So these are the two pieces here. So taking a bit of a closer look, the essentially three features we need here. First of all, of course, canisters must be able to have Bitcoin addresses, right? That is the requirement to hold Bitcoin funds. And that itself requires what is called threshold ECDSA signatures. And that actually is a feature on its own. And there is another community conversation talk later today about this feature. So as far as we are concerned, this functionality is there. So it's we have a very strong dependency on this feature. We assume it's there. So it's not part of what we're proposing. The second part, as mentioned before, canisters must be able to access transactions containing their UTXO set. Right, so it must be possible to get these into the canisters so that they know what they can spend and give them the means to spend it. And third is the ability to actually submit Bitcoin transactions out into the Bitcoin network again. This is actually not trivial because canisters can actually not just communicate with the outside world. Right, so they're very restricted in order to keep them keep the operation deterministic. There is no communication allowed to the outside world other than responses to ingress messages. So this is also a new piece of functionality that is needed. And yeah, what's very remarkable about this proposal is, as you can see, the Bitcoin network is connected directly to the IC, which means there are no bridges in between, no intermediate layer. And this is actually what we mean by direct integration. So we have really replica nodes talking to nodes in the Bitcoin peer-to-peer network. So that is the first remarkable feature. And the second one, of course, is we are actually holding real Bitcoin in the canister. So it's not wrapped Bitcoin. So not another token that somebody promises they would always kind of exchange again for real Bitcoin. These are actual Bitcoin funds that are kind of associated with these canister addresses. And on top of that, we also want to offer a library for developers that provides some convenience functions like get balance, which kind of sums up all your UTXOs, so you can conveniently access your current balance, and also send Bitcoin, which takes care of taking your UTXOs and using the threshold ECDSA functionality to sign all the pieces you need to kind of put together your transaction. So we'll also try to make it easy for the developers and provide at least sample code on how to do this. Okay. Yeah, maybe a short warning here. If you think about Ethereum, you have two kinds of contracts, two kinds of accounts, those controlled by a user, right, with a key, and the second type is accounts controlled by code, which are the smart contracts on Ethereum. And once you deploy or you generate a new account that is controlled by code, this cannot be changed anymore, right? Which is also nice. So nobody can come and change the logic later on. But the problem there is, of course, you should get your contract right the first time because you don't really get a second chance. And the IC has a different model. So when you create a canister, the canister has a so-called controller. And if that controller is a human being, that, as the name suggests, gives the controller control over that canister and it can change it. So some things can go wrong in that scenario if people are not careful. So for example, here, there is somebody who created a canister and that kind of encodes a Bitcoin lending contract. As an example, that gives you 10% interest guaranteed. And the contract is open source, so you can look at it and see that it all checks out. The funds are there, it's guaranteed. And so it looks very enticing because you don't want to sell your Bitcoin, but you would like to get more, right? So a lot of people start sending their Bitcoin to that canister. Now, the problem here is that because there's one guy controlling it, this person is free to operate the canister anytime he wants, and thereby changing the logic. And in this case, the logic now says, well, all Bitcoins are paid to this address, which happens to be the Bitcoin address that this guy controls. So now this person managed to steal everybody's Bitcoin. And nobody did anything wrong, so the technology worked. So the upgrade was legal. All the Bitcoins were transferred correctly. So there's nothing really wrong here. And so what went really wrong, of course, is people were not aware that there is a controller. And in practice, you would have to kind of make sure that before you send your funds, is that controller somebody you can trust? Maybe it's a public figure that you just trust for some reason, or very simply, there is no controller. Because once you remove a controller, it's very similar to an Ethereum contract in that it cannot be modified anymore. And that is just one thing I wanted to point out. There are these little pitfalls that people have to be aware of before spending a lot of money or investing into canisters that are controlled by maybe not so honest people. All right, so coming back to the proposal. So here's the timeline again summarized. Liz already mentioned it. The motion proposal is already submitted. Voting has been ongoing since yesterday, and it will end tomorrow. So for everybody who can vote, please do so before the deadline. All right, and the plan is to, if of course the proposal is accepted, implementation, testing, deployment, and so on will pick up. Of course, we already started testing out a few things. And the goal is still Q4 of this year. But remember, we have this hard dependency on the ECDSA threshold signatures. So if that were to take a bit longer, that would also delay the rollout of Bitcoin integration. But we're hopeful that we can do Q4. And if testing takes longer, then it might be Q1 next year. All right, so that's all I wanted to say about the proposal, and to hope everybody now has a good idea about the goal and the things we want to achieve. So now let's look at some technical details for those of you who are interested. Again, let's start kind of high level. These are the 4 layers of the IC of the internet computer. We have execution at the top, message routing, consensus, and networking at the bottom. The networking layer will be responsible for ingesting the Bitcoin blocks. So the connection happens here. Blocks go through the stack up to a new BTC system component. So it's really part of the replica system of the IC system. The component will make UTXOs available to canisters, and it will accept transactions, and also state information will be made available to the lower layers for the interaction with the Bitcoin network. And of course, the threshold ECDSA part is used to actually sign the piece of data to create transactions, which also goes through the entire stack. So the important message here, of course, is that when Bitcoin blocks come in, they traverse the whole stack as well. So there is consensus at the execution layer about the block that is currently being processed. And the system component state will be updated deterministically. So that's the high level view. If we look at the same thing in a bit more detail, picture becomes a bit more colorful. Again, starting at the bottom, so it's the same thing. If we look at networking, well, we see there are actually multiple pieces. We have a Bitcoin adapter, which understands Bitcoin and interacts with the Bitcoin network. We have an adapter router that takes care of all the adapters, because there will be more adapters coming in the future. And the interaction with consensus happens through the standard functions like create payload, validate payload, before having the block bubble up to the execution layer, where it will be processed by the BTC system component. And the persistent state of the BTC system component is made accessible through the state manager, which allows the networking components to get the state. And with that state, the Bitcoin adapter can determine what Bitcoin block to suggest next in the next payload, if any. All right, so this is how the whole circle kind of works. And maybe one more thing that is important here. So we have all these kind of APIs defined, but these are, of course, subject to change. So this is more or less how it will work. but details, of course, may change. Like these are probably not the very precise signatures as they will be implemented later on. And if we now go to each individual layer, we again, we see that there's actually more to it than in this big overview slide. If we look at networking and consensus, for example, we see that, well, the adapter, router, and the Bitcoin adapter are actually joined by another component, which is called the networking transit, which actually establishes connections to Bitcoin nodes. And the reason is simply a replica has very, very strict firewall rules because, as I mentioned before, a replica is not meant to talk to the outside world. So we need a special component that can actually bypass these restrictions and make connections to the outside world. And they will go through this new component, the networking transit. The Bitcoin adapter, as I mentioned before, actually holds the Bitcoin state and it understands the logic. So it knows how to interact with the Bitcoin network, the inventory messages, and which block headers to request, and the corresponding transaction blocks and so on. And the adapter router is actually Bitcoin agnostic. It would just take a request from the consensus layer. It would see that this corresponds to a request that has to be served by the Bitcoin adapter, forward it, and get the response back for consensus. So this is the networking layer. If we move up to execution, again, just providing a bit more detail here. As I said, the Bitcoin block comes through consensus. Message routing will make it available to the BTC system component, where it will be put in a structure of recent blocks. And once a sufficient number of confirmations are collected for a certain block, the UTXO set will be updated, and it, in addition, stores all the transactions coming from the canisters running on that subnet. And the functions that it provides, put transaction and get UTXO set, again, the names and signatures might change a little bit. They will be exposed to canisters using the virtual management canister. Okay, so that's already all I wanted to say about how we are planning to integrate Bitcoin. I'd like to just say a few more words about alternative designs that we consider, right? You might be wondering, why are we doing it this way? And you might have ideas on how to do it differently. One thing you could, of course, do is just have a canister, right? You might say, well, why do we have this system component? A canister can hold any logic, so we might just have a single Bitcoin canister that essentially stores UTXO and does all those things, and we just interact with that canister. Well, just looking at the picture, you might see, well, there are some obvious drawbacks. One, of course, is that the single canister would be a bottleneck. So there's a question around scalability of this approach. Also, if we have a canister, what about cycles, right? Does it have to pay for cycles or not? So if it has to pay, who will top it up? And what happens if it runs out of cycles? So those are some issues. And of course, it's also not very elegant to have all these lower level architecture pieces kind of depend on a user level component, which is this canister. So they would kind of, you would have to ensure that this user level canister is always there so that the Bitcoin adapter has a recipient for the blocks. Alternatively, you might say, well, the scalability might be solved by just having one of these Bitcoin adapters per large subnet where we provide this Bitcoin functionality. And through this, we could solve the scalability issue. But of course, we still have the problem that we need to manage the cycle somehow. So we still need somehow a special type of canister And moreover, routing might become a bit of an issue because we need to define the address of this canister. So if it's all the same for every subnet, we would have multiple canisters with the same address, which is kind of weird. We could have different ones because they're in different subnets and they're actually different canisters. But then the question is, so how do nodes figure out what canister to route to? How do they find the one for their subnet and so on? So there are many issues we found with these approaches, and that's why we kind of settled for a kind of deeper integration as a system component that kind of eliminates most of the problems we saw here. Okay, and that brings me to the end of my presentation, and we can start the Q&A session.
Amazing. Cool. Thank you so much, Thomas, for that overview. So we can go ahead and dive into the Q&A. So first up on the docket, Thomas, is the Bitcoin address add-on opt-in, or are all canisters going to inherit this behavior? Does this add any execution overhead for pure Motoko and Rust canisters?
So it will not be available on all subnets. So because for some security concerns, this will only be available on larger subnets. But the idea is to have this kind of rolled out on all these larger subnets. So they will all have it. And if your canister ends up on one of these canisters, it would be able to make use of the functionality, but of course it doesn't have to, right? That is one half of the answer. The second part regarding overhead, this is of course to be determined. So we still have to build it, but based on how we see it, if you're not making use of it, this should not put a lot of stress on the subnet the way we see it, especially for Bitcoin, which has a very slow block time of 10 minutes on average. We don't expect this to have a major impact.
Okay, so clarifying question, Thomas. So you said just now that this functionality is only available on certain subnets, right? Larger subnets. So what determines if a subnet is large enough or too small for this sort of functionality?
That is a good question. And to be honest, we don't have a definitive answer for that question yet. So the problem, of course, is if a subnet is very, very small, right? Let's say a four node subnet, and people send hundreds of thousands of Bitcoin to that subnet, and there are only 4 nodes. So the node providers might feel like it's better just to break open their replicas and try to steal a Bitcoin, right? And if it's a larger subnet, this becomes much harder because you need many more people kind of colluding to make this work. So that is the motivation to keep them large. But then the question is, okay, so how many do we need, right? Like, is it in the 10s or 20s? That is not decided yet, but it will be, I would say at least 13 up, maybe 20, 25 up, in the order of the size of the NNS.
Okay, thank you, Thomas. So next question, just curious, how can a user see their Bitcoin address? Will there be any dApp built for features like showing Bitcoin addresses, sending Bitcoin, and so on and so forth?
So this can be, I would say, built fairly easily. So what we do provide essentially is the basic mechanism, like getting your UTXOs and so on, to enable people to build such things on top, right? So you could very easily build such a lookup service on your own. So we don't want to provide, too many little things that people can just as well build as a canister.
Okay, awesome. Thank you, Thomas. Next question. How will you ensure you are connecting to a sufficient number of Bitcoin peers to ensure probability of honest blocks? And will blocks be validated by the replica? So
answer the questions in reverse. Yes, they will be validated. So we will first of all look at proof of work that went into the block. And of course, when updating the UTXO, we can look at all the transactions to see whether they actually consume UTXOs. So the validation happens. It actually happens already when ingesting. So we don't want adapters to get a bad reputation because they try to get bad blocks into the replica. So we will actually do basic validation already when receiving Bitcoin blocks in the adapters. And then later on in the execution, they will be validated again. And what was the second question again?
Oh, the second question was, how will you ensure you are connecting to a sufficient number of Bitcoin peers to ensure probability of honest blocks?
Yes, so there's a large number of Bitcoin nodes out there, like 13,000 or something. So the current plan is to have each adapter learn about a large portion of the network through network discovery, and then try to connect to a random subset, so a fairly large random subset, and then also cycle through these connections to obtain blocks from different nodes all the time. And every replica does this. So all in all, in just a single subnet, they will cover a large portion of the Bitcoin network. So yeah, the whole thing only fails if every adapter manages to connect to a bad node with all the single connections it tries to open. So this probability should be very low.
Okay, thank you, Thomas. Next question, is the adapter router going to be the foundation for general outgoing HTTP functionality?
In short, yes. So we are also looking into providing another nice piece of functionality, which enables canisters to make HTTP requests. And that the idea, of course, is to make use as much as possible of the pieces we're building for the Bitcoin integration. And an HTTP adapter will also be, or there's a current plan to have an HTTP adapter also connected to the adapter router to make these kind of calls possible. Yes.
Great, thanks, Thomas. Next question, are other internet protocols possible with the adapter router, like UDP, TCP, WebSockets, etc.?
That is, I would say, too early to say. So at the moment, what we're building, of course, is geared towards Bitcoin, which will use standard TCP connections to these nodes. But even for, yeah, we will also think about other protocols, like for the HTTP, which goes over in, yeah, for the HTTP handler, we will look into what is needed there, whether, or for other protocols, UDP might be appropriate, but this is not defined yet. So we'll just add it as it becomes a necessity.
Okay, thank you, Thomas. Next question, say there's a contract that someone wants to run for years, but during that period, it runs out of cycles and nobody notices it or nobody tops it up. Does that mean the canister could get deleted and the BTC would be lost?
That is a good question. There is a, so that is actually a question that my short answer would be no, but that is a question that should be asked in the threshold ECDSA feature talk or Q&A session afterwards, because they are really looking into these kind of issues. So for me, I would say I don't need to worry about it. So they are kind of worrying about the security aspects and what happens when things get lost or a subnet breaks down. So I would say we should keep that question and address it in the Q&A. I mean, I would say no, but just to be sure, I would ask people working on that feature.
Yeah, and everybody, the threshold ECDSA, ECSDSA, oh my God, the talk that Thomas mentioned, it's very early in the morning, is happening later this afternoon at 2:30 p.m. PT. So I'll send across the link in the chat in a bit. Okay, and I see, I'll note that question for the talk and I'll ask it to Victor, who's the speaker. Okay, next question. Also, where is the private key of the Bitcoin address saved and how secure is the saved private key?
Yes, so again, this essentially is about a distributed or threshold ECDSA, but I can still say a few words about it. So the idea is the private key is not stored anywhere. So instead, what happens is the private key is kind of split into shares. So we have private key shares, which by themselves don't tell you anything about the private key. Okay, and each replica has access to its private key share. And in order to sign a message with the private key, they need to run the protocol that Victor will talk about later today to come up with a signature using the private key. So the security is derived from the fact that no single node has access to the key and it's not stored anywhere.
Thank you, Thomas. So next question. So this individual is saying, I'm not sure if I understand this right. Would the canister hold the private key for its own BTC address? So if there was one evil node on a subnet, could it send the BTC to the bad node's operator address?
Yeah, so that kind of ties in with my previous answer, right? If you want to send Bitcoin away, you need to be able to spend the UTXO, which typically requires a signature on some piece of data. And for that, you need to run the distributed protocol across all the replicas. And the reason is because you don't have access to the private key on your own. So a single malicious node does not have any authority over the funds stored in the canister. So that would not be possible, this type of attack.
Great, thank you. So next question, if a user loses access to the IC wallet, will there be a backup seed phrase if he holds Bitcoin to recover?
So there are a lot of questions about the ECDSA part, which is understandable. Again, here, Victor and others in the team are thinking about how to make this as secure as possible, including mechanisms to kind of back up keys in case the whole subnet burns down. So they are looking into this. Yeah, so again, I would say, yes, this is taken care of. So we're aware of all these security problems. And of course, people are worried and so are we, right? We're trying to really cover all the angles. But the details on what security guarantees we can actually provide and under what conditions would it still be safe and what kind of disasters we can handle, this is a question for Victor and the team.
Okay, thank you, Thomas. So for those of us on the call, CycleDAO produced a really good write-up on this proposal that was published yesterday. So I wanted to go over some of the community topics that were and feedback around this proposal that were brought up in the write-up. So one of the concerns that was raised by the community was, so IC replicas will basically have Bitcoin Core running as well, or will they all talk to a smaller set of Bitcoin Core nodes? If each replica doesn't have its own Bitcoin Core nodes, there are centralization risks. And if they do, it seems like we're now tying Bitcoin consensus into the internet computer. So Thomas, not sure if you have some thoughts on this particular piece of feedback.
Yeah, so they're kind of assuming that we're kind of connecting to a small set, right? And then there's a certain risk, a small set of Bitcoin nodes, and that poses a certain risk, right? If we were to do that, because who knows if they're trustworthy. And we are trying to kind of mitigate that risk by not keeping the set small at all, right? We're connecting to random nodes, to many random nodes on every replica, so to different nodes, to make sure that the risk of having a kind of a collusion attack against the nodes that we're talking to is negligible.
Great, thank you, Thomas. So some other community feedback from this write-up. Subnets will be able to hold and control real Bitcoin and Ethereum for the Ethereum proposal. It is of paramount importance to ensure that Bitcoin or Ethereum are neither lost, for example, because the subnet failed and can't be recovered, nor stolen, for example, because sufficiently many node providers collude to extract the secret key material. So what are your thoughts around containing these risks described?
Again, as I mentioned before, this is really something I think these kind of questions keep Victor up at night, and Jens and others. So they are really, really looking at all these problems, and there are discussions around subnet size to make sure that it's very unlikely that sufficiently many node providers come together to break into their own nodes to retrieve their keying material. So we are looking into this, and I think maybe what we can learn from these questions is that the community obviously is also concerned, right? So they're all raising very, very good questions, and yeah, maybe we need to provide maybe also a good write-up of how we're planning to address all these issues and to what extent we can mitigate them. So again, I'm assuming that Victor will go into these kind of challenges in his talk.
Okay, I've noted all of these questions for Victor preceding Victor's Q&A. Thomas, next question. So given the need to replicate the BTC chain state into the IC, how will this affect the subnet's capacity?
Yeah, so currently, so the estimate is we'll have to store the UTXO set. Current plan is to store the entire set, which would take roughly 10 gigabytes of storage. And that is the biggest piece. We'll also store recent blocks, which adds a couple of megabytes, which is not a big deal. And then the outgoing transactions, which are also kind of small. So in terms of memory, if we, again, take the magic 300 gigabyte number of available state, it is actually still a rather small portion thereof. So again, as I mentioned before, we don't assume this to have a major impact. And of course, in the future, we also want to go into subnets with a lot more state than this, and also much more storage. So this initial 10 plus gigabyte of additional storage, yeah, we should be able to handle that.
Okay, thank you, Thomas. So next question, do you think this will enable more people to more easily do algorithmic trading, or is this more about allowing smart contracts rather than cloud-based software to control the trading?
Actually, I'm very curious. We never had proper smart contracts for Bitcoin, right? We all have all these wrapped solutions. So this will be the first time we can actually use Bitcoin and have arbitrary contracts, and you can build any type of logic. And I have really no idea what people are going to build, but I'm hoping they're going to be very creative and come up with these kind of things, running all kinds of DeFi applications using proper Bitcoin as the base currency.
Okay, thanks, Thomas. So one question, so we have open proposals to integrate with Bitcoin and Ethereum. What about other potential networks like Polkadot and Cosmos? Or is that something the community will have to bring to a vote?
Yeah, so for now, the current plan is to focus on Bitcoin. And as everybody knows, the next step would be Ethereum, because that's also an interesting integration. So we're doing Bitcoin, of course, because it's the most well-known and the biggest market cap out of all the cryptocurrencies, and it lacks smart contracts. So it's a very obvious first choice, in my opinion. Ethereum is also interesting because it has many cool contracts running on it, also in the DeFi space. So that also makes it a clear number two. And that is actually the roadmap that we have for now. So there are no further integrations planned. And yeah, but then the question is, what would we gain from incorporating others, right? One thing, of course, is you might say we integrate as many as we can because the internet computer will become the hub for all blockchains. That is one view you might take. But on the other hand, you might say, well, you can do everything on the IC. You can write any kind of logic, and it has the main cryptocurrencies kind of integrated. So maybe additional gain would be small for additional ones, right? So you could take either stance. And yes, so it will be up to the community to just make a case for further integrations and whether that makes sense or not. And we're definitely open to hear what the community has to say.
Great, thanks, Thomas. So next question, will this integration improve the throughput of Bitcoin transactions in any way?
Yeah, again, this is so the short answer is no, right? Because we're actually interacting with the real Bitcoin blockchain, and we cannot make that one run any faster. So it will always have this 10-minute average interval between blocks. So that doesn't change anything there. So even on the IC, you would have to wait 10 minutes or an hour if you're waiting for 6 confirmations. Dom, in one of his tweets, mentioned Bitcoin transactions in 2 seconds, and maybe the question is kind of around that, right? So where does that come from? And of course, if you want to have faster transactions, we would have to kind of wrap Bitcoin ourselves. So we could have a canister that provides essentially some sort of a liquidity pool where you can send Bitcoin and it would give you IC Bitcoin in return. And that, of course, these Bitcoin you can then trade at the speed of the internet computer, which would bring the transaction time down to just a few seconds. So the main difference, of course, to other wrapped Bitcoin solutions is that you're wrapping your Bitcoin on the IC itself, right? Because the IC can hold Bitcoin. So you wouldn't have to go through some exchange, some other service to get your wrapped Bitcoin. Everything would be running there, and you can actually verify the contract that yes, I can lock my Bitcoin up, and when I want them out again, I can easily request it. So that would be that's how you get to shorter transaction times.
Okay, thanks, Thomas. So next question. This individual says, I thought there was no way that node providers can know what canisters are running on their hardware. Is that not true? And if they know what canisters are running, how can they see the state of those canisters? And is this possible?
I'm actually not so sure what it is that they can see or should be allowed to see, but the truth is they do have access to their nodes, and they might be able to read out quite a bit of information about the canisters running on there, right? So yeah, I'm not sure to what extent that is kind of considered a problem, right? Because it's we don't have any really privacy guarantees that a node provider cannot see the data on it. But in any case, for the integration that we have here, as I mentioned before, even if a node provider gets access to a canister or gets into kind of reads out the state of a replica, this would not allow the node provider to kind of transfer Bitcoin funds out. So even if a node provider gets kind of illegal access to its own nodes and reads out memory, this by itself would not be problematic.
Okay, and the person who asked this question had a couple of clarifying thoughts. So they're saying this question pertains to them building the key from the pieces, which they said you had mentioned as a possibility to get a Bitcoin key. And we also had a community member in the chat say that it's probably just a best practice to assume that it is possible for node providers to know what canisters are running because they do have physical access to the nodes.
Exactly, they have physical access after all. So from a security perspective, we just assume they can see everything, right? And we want to build a system in such a way that even if they see the state of all their replicas, it should still be secure.
Okay, thanks, Thomas. So our next question is the final question, unless there are last-minute questions coming through in the Q&A. So Thomas, thus far, just in general of how the vote is currently going for direct integration of Bitcoin with the internet computer, as well as general community sentiment, it seems like most people so far that we've seen are leaning toward yes on this proposal. But just to play devil's advocate, what are some of the reasons why somebody would vote no, and what are your thoughts around that?
It's a very good question. I don't know if you can tell, but I'm in favor of accepting it because I think it adds a lot of value. So both to the IC as well as to Bitcoin, you can do things you could not do before. So trying to understand why they would vote no. Well, of course, what we're doing is very invasive, right? So we're adding a lot of Bitcoin pieces into our stack, which you might consider somewhat not so elegant, right? So to have this kind of deep integration of just one particular other blockchain. And yeah, maybe their idea is to keep these worlds still a bit more separate. So even if we have Bitcoin support somehow, but not kind of spend all that effort, which is a lot of effort, just to have such a tight integration for something that doesn't have clear ties to the IC. It's a completely different thing. We're doing smart contracts. This is like more of a store of value. Maybe they don't. I would say maybe they don't see the point of why we need to spend such a huge engineering effort to kind of connect these worlds. That would be my guess. I personally don't see any good reasons not to accept it, but actually I would be very much interested to hear from people who voted no why they think it's not a good idea. So maybe I can, in the forum or elsewhere, I can hear more opinions. That would be interesting.
Turn the tables and hear
Exactly.
from the users. I think dissent and having opposing opinions is very healthy for an ecosystem. So if anybody has voted no with this proposal or is leaning toward no, would love to hear your thoughts as well. So we do have one question that has just come through. So actually two questions. Wow. So could you talk about what you see this proposal can make possible, i.e. direct integration of Bitcoin with the internet computer that people couldn't do with, for example, the Coinbase Pro API or wrapped Bitcoins?
Well, in short, if you can use wrapped Bitcoin and you do that on a platform that gives you all the power to write your smart contracts, it doesn't really give you more. But so the kicker here, of course, is we are doing smart contracts with Bitcoin, right, and nothing else. So this is a big step. So we don't need this intermediate translation to some wrapped Bitcoin. So it feels more like a native solution, so to speak. So I think that is a big difference. And you don't need to trust anybody to exchange your wrapped Bitcoin for actual Bitcoin. That this whole step goes away. So that is, I think, what makes it kind of stand out compared to other solutions.
Okay, thank you. And the next question and final question thus far does have a legal slant. So Thomas, if if you're not sure, that's a totally valid answer. But it is an interesting question, particularly for developers and entrepreneurs who are looking to build on the internet computer. So the question is as follows. What about the legal ramifications of a company or project building on the internet computer that they don't know who the node providers are or where they are, and these node providers have access to your project's data, which might have, theoretically speaking, a chilling effect on people wanting to build on the ICA. So from our perspective, is there any more light we can shed on the topic to assuage some of these concerns?
But this is not tied to Bitcoin integration at all, it seems.
No, but it's a follow-on question from the question before around if node providers can know what canisters are running on their hardware. But again, if that's something that is out of scope, that's totally valid for you.
Maybe all I can say is, even for the Bitcoin integration, we did raise some legal questions, like what does it mean for a canister to hold Bitcoin? Does that mean the node providers hosting these need to pay some sort of tax for that, and so on? So we are also looking into these type of questions, actually. And I also reached out to legal people at Dfinity to discuss these type of questions. So we, and as you might expect, we didn't get a clear answer yet. So even lawyers don't know.
No surprises there.
Exactly. Lawyers don't know what that means and whether it, qualifies as a certain thing or another, and how the laws would kind of see it. So the two parts to the answer. One is we are looking into these legal aspects and see whether there's any danger, right, we should be aware of. And the second part is, so far lawyers are not sure, and that means I'm not sure. I don't know more than the lawyers.
Very fair, Thomas. So we are just about, wrapping up in terms of time. So unless anyone has a very last minute question, thank you, Thomas, so much for this very clarifying talk around the ongoing proposal for direct integration of Bitcoin with the internet computer. There's a lot of positive feedback in the chat. So people are saying, awesome talk, Thomas. Thanks, Thomas. Thanks for the nice talk and all of this work. So for everybody on this call, remember the deadline to vote on this particular proposal is tomorrow. So if you haven't voted already, whether your vote is yes or no, please get your votes in. And that is so crucial for the decentralized aspect of the governance of the internet computer to work out. So again, it doesn't seem like anyone has any last questions. Someone also said you had a nice voice, Thomas.
Thanks a lot.
All right. Thanks again, Thomas. Thanks again, everyone, for tuning in, and see you at a future community conversation. Bye, everyone.